Hello everyone. In the previous lesson, we learned about the method of reading smart contracts to query and read the relevant data information stored on the blockchain. This operation is usually to obtain the necessary data as a reference for business processing. Since reading a smart contract does not make any changes to the blockchain, there is no Ethereum gas to pay. In this lesson, we will learn how to send ETH, which is a practical example of a write-to-blockchain operation. Sending ETH means sending Ether or another cryptocurrency from one Ether address to another and creating a new transaction record. This process modifies the state of the blockchain, so it needs to consume enough gas to cover all the costs incurred during the execution of the transaction. Computation costs, storage costs, etc. A fee is also paid to the miner so that the transaction is validated and included in the next block. Writing to the blockchain is the process of adding new data to the blockchain network that will be permanently recorded on the blockchain. To write new data on the blockchain, the following steps are performed. The first step is to create a transaction. Package the data into a transaction and submit it to the blockchain network because each transaction needs to be reviewed, processed, and validated by a miner. A transaction fee, that is gas, is required. Gas represents the amount of computer resources consumed. When the transaction is executed, gas will be used to calculate the actual cost of the transaction, which is used to encourage miners to validate the transaction. Step 3. The miner reviews and processes the transaction and packages it into new block. The block contains multiple transactions as well as the hash of the previous block as proof of linkage. Eventually, the new block will be broadcast throughout the network for validation and synchronization, thus updating the blockchain with new data. Due to the decentralized nature of the blockchain, stored information on all nodes remains consistent and unchanging. Writing to the blockchain enables traceability and transparency of information, thus enabling the security and trustworthiness of transactions in the digital world without the need for third-party certifiers or intermediaries. Here we go to the operational steps of writing to the blockchain. Writing to the blockchain refers to permanently storing the transaction records on the blockchain for verification and sharing by all nodes. Generally, writing transaction records to the blockchain requires the following steps. First step, create a crypto wallet and get the address. This is usually done using the Ethereum network and can be done through many different wallet programs or hardware wallets. After creating the wallet and address, make sure there is enough balance in that address to pay the gas fee. The second step, construct a valid transaction and sign it. For smart contract transactions, the transaction data should follow the required specifications. The third step, send the transaction to the network. At this point, you need to specify the parameters of the transaction, such as gas price, gas limit, and nonce. Step 4. When the transaction is packaged by the miner and added to a new block, the transaction is confirmed and written to the blockchain. This is done so that the transaction information is broadcast across the network, even if its validation is still pending. It is important to note that writing to the blockchain may vary from application to application and may involve additional details and security measures in practice. For example, during the process of writing to the blockchain, gas fees must be paid to incentive miners to verify and process transactions. The amount of these fees is based on the size of the smart contract code that needs to be executed and the computational resources required to run it, and may also vary slightly on different networks. When writing new data to the blockchain, the following parameters need to be provided: the content of the transaction, what information is to be written to the blockchain, that is usually the address of a smart contract, data of function call, etc. Second, sender address. It is the address of the wallet that initiated the transaction. Third, receiver's address is the destination address to which the data is flowing, which may be null in some cases. Nonce is a random number for the sender's account, which is limited to being used only once. Nonce random number is an integer, which can only be used once and is used to prevent transactions from being executed or changed repeatedly. Whenever a new transaction is initiated by the sender, the nonce value is automatically incremented by 1. When an account submits more than one transaction in the same block, the nonce must be consecutive to the nonce value of its previous transaction. Otherwise, the transaction will be considered invalid. There are two main factors related to the cost of a miner: gas price and gas limit. When sending a transaction, the user needs to set both values to determine the maximum gas fee, that is, the handling fee, that they are willing to pay. For gas price, it's the actual cost per unit of gas set by the sender. In the Ether network, the gas is a unit of computation required to execute a smart contract. Each transaction costs a certain amount of gas to complete, and the price of gas is determined by users on the blockchain through bidding. Thus, gas price refers to the price of ETH per unit of gas. It is usually expressed in units of weight, where weight is the smallest divisible unit of Ethereum. The higher the gas price, the higher the likelihood that a miner will be willing to include the transaction in the new mine. Miners will choose to prioritize transactions with a higher gas price because it allows them to earn more fees faster than other transactions and cash the next block out. Conversely, If the gas price is too low, then the transaction may be put outside a block and wait for a transaction with a higher gas price to be processed before it is processed. As for gas limit, it is the maximum amount of gas required for a transaction, limiting the upper limit of gas for a transaction to prevent triggering errors or unexpected situations during the execution of the transaction. From a computational point of view, gas limit can be understood as the maximum resource consumption required for transaction execution. Each operation code, for example, addition, subtraction, storage operation, etc., needs to consume a certain amount of gas to be executed. During the execution of a transaction, the gas consumption of each operation will be recorded until the gas limit reaches the upper limit of the transaction, or the execution of the transaction is completed. Gas limit refers to the maximum amount of gas allowed by the exchange. It determines how much gas the transaction will cost to complete. If the transaction execution exceeds the set amount of gas, then the transaction will fail. This also means that the higher the gas limit, the more gas it will take to complete the computation, and the higher the transaction fee will be. On the contrary, if the gas limit is set too low, resulting in the transaction being executed incompletely or failing, it will need to be resent and an additional fee paid. This means that even if the transaction fails, the sender will still pay the base fee in the transaction fee, which is a fixed fee independent of the amount of gas used. This is because the base fee is paid to the miner to ensure that the transaction is included in the blockchain. Therefore, the base fee must be paid regardless of whether the transaction is successful or not. Of course, if the transaction fails, the sender will get a refund for the unused gas, and the total cost of the transaction is equal to the gas price multiply gas limit. It is important to note that different dApps or wallets will preset or suggest different recommended gas price levels based on their own logic and purpose, and as the number of transactions and buying business on the Ethereum network keeps changing. The appropriate gas price needs to be adjusted in real time. In order to ensure that your transactions are processed by miners as soon as possible, you can yearly check the latest network status and reasonably estimate and set the gas price according to your needs, so as to ensure that your transaction can be processed quickly and fast and safely. Let's look at the last parameter, signature. It is a digital signature signed by the sender, providing the authorization and approval of the sender for the transaction. It is important to note that a digital signature is one of the steps necessary to guarantee the security and correctness of a transaction in any case. Transactions that are not digitally signed are always invalid and cannot be verified and written to the blockchain network by miners. For example, The FMZ platform handles the details of digital signatures automatically, so the signing process is not explicitly shown in the code. Anyway, these parameters are usually sent via a wallet, a blockchain browser, or a web3 based application and are verified and processed by the miner nodes. Upon successful writing to the blockchain, the new data are recorded on the blockchain and can never be deleted or modified as they become part of the hash value of the next block in the chain. Finally, as a warm reminder, the operation of writing to the blockchain may vary in different application scenarios, and more details and security measures may be involved in the actual operation. Therefore, you need to read the relevant documentations and guidelines carefully and follow the best practices to ensure security and correctness. And we will have a demonstration of sending ETH code in the next lesson. And we will see you in the next lesson. Thank you.